So we're going to be looking at the surface area and volume of cones. Now I trust that you know what a cone is because when I think of cones, I think of ice cream cones. And so the cone is this beautiful three-dimensional object with a circular base. So if I'm looking for the surface area, remember the surface area is the total area of all the flat faces added together. So hopefully you can see that there's definitely going to be a pi r squared, because if we have a pi r squared, that's the area of the circle. So we just need the area of this sort of conical surface area. And so that's actually going to be pi r times L. Just like pyramids, L stands for this lateral height. So it's this distance here. And I'm going to add that to the area of the base, which of course is pi r squared for our circle. Volume is nice because it's actually the same formula as a pyramid. If you remember, a pyramid has the formula 1/3 of the base, area of the base, times the height. The height is measured from the center to the apex, or the tippy top, of the cone or pyramid. Well, the area of the base, because it's always going to be a circle for a cone, is pi r squared. So we can also say that this is 1/3 of pi r squared times h. This is the same formula because the area of the base is pi r squared. So let's get some example problems in, and let's start by looking at the surface area. So the surface area, again, is going to be pi r L plus pi r squared. So the surface area is going to be pi times the radius, which is 7, times the length, which is 15.7, plus the pi times the radius again, except squared. So if we multiply 7 times that initial pi times 15.7, and we add that to 49 times pi, we are going to get that the surface area is 499.20 miles squared. It's a pretty big cone. For the next one here, we can see we have a diameter of 16, so that means that the radius is 8. So the surface area is going to be pi r L plus pi r squared. So again, we have the surface area is pi times the radius, which is 8, times the lateral height, which is 17.9, plus pi times the radius, again, 8 squared. So multiplying this all together, we have pi times 8 times 17.9, and we add this to 8 squared, which is 64, times pi. So this surface area is going to be 650.94 inches squared. For the volume, again, volume is going to be 1/3 the area of the base, which is pi r squared, times the height. So we're going to have 1/3 pi r. Here we can see the diameter is 6. So the radius must be 3, times the height, which is 7. So, of course, I'm going to have 1/2, which is also the same as 0.5, times pi, times 3 squared, times 7. And once I calculate all this, I get that the volume is 98.96 feet cubed. For this last question here, volume is 1/3 of pi r squared h. So the volume is 1/3 pi. The radius here is 12. So that's 12 squared times the height, which is 24. So the volume is going to be equal to, ooh, you know what? Sorry, I wrote this as 1/2. So I made a mistake with number 3. Very sorry about that. I can't read my own handwriting. Going back to number 3 real quick. This is 1/3 pi times 3 squared. So it's actually 1/3 times pi times 3 squared times 7. So that's actually 65.97 feet cubed. Sorry for the confusion on that one. So over here, I have again 1/3, not 1/2, times the pi times 12 squared, which is 144, not 24. 24 is 12 times 2. And that gives me a volume of 3,619.11 centimeters cubed. So as long as you know these formulas, and hopefully you recognize the formula for the volume of a cone, because that's the same for the volume of a pyramid. We find the area of the base multiplied by the height, and 1/3, not 1/2. So if you can do these, then you should feel comfortable doing any problems involving surface area or volume of a cone.